Hi everyone, welcome to my calculus lecture. In this lecture, we study mean value theorem. First, we are going to talk about something called Rolle's theorem. So, what is it about? Here's the statement. Let f be continuous on the closed interval ab and differentiable on the open interval ab. If f of a equals f of b, then there exists a number c in that open interval ab such that f prime of c equals 0. You know, in fact, if you draw a picture, this can be easily understood. So I am going to draw a so let's say that this is A and this is B. Okay, so we are considering a continuous function on the closed interval AB, and so let's just assume that you know uh, here f of A and f of B are the same. Okay, so that's f of A and also that's f of B. Okay, so it's continuous function. Okay, right? So it's going to be something like that. Okay, or it could be the so you can try like any kind of like a different shape, but what you no matter like what kind of uh, the example you are trying, always you will find that, right? uh, so uh, let me draw that again. So at least there is a one point C between A and B such that the slope of tangent line, so slope of tangent line is horizontal. I mean the tangent line is horizontal, okay? So slope equals 0, all right? It could be instead of this, or it could be something like more, I mean simple. So it could be something like you know that kind of picture also. Uh, any no matter what kind of the graph you have, you will always find that between A and B there is at least one C. Okay, there is at least one C where the uh, the tangent line is just horizontal line. In other words, f prime of C equals 0. Okay, right. So here, like a crucial condition is that f of A equals f of B. If not, then this is not necessarily true. Okay, excuse me. All right, so here's an example. Show that the equation x cubed plus x minus 1 equals 0 has exactly only one real root. Okay, this equation has exactly only one real solution. So Rolle's theorem allows us to answer this question, right? So let's see how that works out, okay? So here's an example. Let's let f of x be the function here. Okay, so x cubed plus x minus 1. Okay, so then f of x is continuous. I mean, this is a polynomial, so it is not only continuous but also a differentiable function, right? Everywhere, in fact, right. Here, f of 0, right? F of 0 equals -1. On the other hand, then f of 1 equals 1, right? So they are different. A while back, we studied a theorem called the intermediate value theorem. Remember that? So in this case, by the intermediate value theorem, we see that there exists at least one root, at least one root of the f of x. Okay, f of x. In other words, x cubed, so the root of f of x in the interval, open interval 0, 1. Okay, 0, 1. In other words, the root of f of x means, the equation x cubed, right? X cubed plus x minus 1 equals 0 has at least one solution. Okay, one solution, right? But what we are trying to prove is what? There has been only one. So we know for now, due to the intermediate value theorem, there is at least one, but there can't be two, right? That's what we are trying to show. So how do we prove something like that? Well, this is like a typical method in mathematics. So what we do here is that let us assume that there are two. Then if we stumble upon based on that the hypothesis, right? We stumble upon a contradiction, logical contradiction. Then since this logical contradiction is due to our assumption, so our assumption was wrong, right? So that's the way we can to prove that there exists, right, exactly only one root. So this type of proof is what? Proof by contradiction. Very common method of proofs, in mathematics. Okay, so that's what we are going to do. So we suppose that there are two roots. Okay, so there are two roots a and b. Okay, a and b. In fact, the A and B, I mean, the one has to be smaller than the other since they are different, right? So without loss of generality, right? Without loss of generality, we can assume that A is less than B, right? So these guys exist in 0, 1, okay? Open interval. So here, as abbreviation without loss of generality, okay? So we can assume that A is less than B. Then since A and B are roots, right? Then A and B are roots, so both A f of A and f of b are equal to 0, right? Equal to 0. So by Rolle's theorem, there has to be, there exists, right? There exists a number c, okay? A number c in the open interval a, b such that, okay, such that f prime of c, okay, equals, 3c squared plus 1 equals, you know what? Let me, I mean, yeah, okay, so f prime of c equals 0, right? That's what the Rolle's theorem says. However, however, f prime of c is, f prime of x is 3c squared plus 3x squared plus 1. So it's gonna be 3c squared plus 1. No matter what c value is, 3c squared plus 1, this is always positive. It can never become 0. So what do we have? We have a contradiction, okay? A contradiction. Okay, a contradiction. So the conclusion, therefore, where, by intermediate value theorem, at least we know that there is one solution, but that's the only solution. That has to be, because if we assume that there are two, then we get into trouble, okay? So there exists only one real root of f of x, okay? So that completes the proof, okay? This completes the proof. Okay, so now we are going to talk about another theorem, which is called the mean value theorem. Okay, so usually abbreviated by MVT. So what's the statement? Let f be continuous on the closed interval AB and differentiable on the open interval AB. Then there exists a number C in that open interval AB such that f prime of C is the same as this guy, right hand side, f of b minus f of a over b minus a. You know what it is? Have you noticed that? The quantity in the right hand side is nothing but what is that? The slope of a line segment joining the point A f of A and A f of B, right? So there's at some point, right? The tangent line is parallel. Tangent line is parallel to this line segment. Line segment joining those 2 points, end points actually, right? So end points of the right the what is the line segment? Okay, right. So let me draw a picture first. So here's my A, here's B. Okay, so let's say this is f of A, and that's f of B, so that's f of B. So in other words, this point is A, f of A, and this point here is B, f of B, okay, right. So the line segment joining these two is going to be this guy here, okay, right, line segment. So slope of this is going to be, right, so the slope of this line segment is f of B, as you know, f of A all over B minus A. Okay. Let's say that our function, let's consider like a kind of simple type of function like that. Okay, so a continuous function. So that's f of x, right? F of x. Then from this picture, you can see that from this picture, there's some point. There's a point C somewhere between A and B, where the tangent line is parallel to tangent line. Yeah, tangent line is parallel to this line segment. Okay, so in other words, this guy equals f prime of C. So two parallel lines have the same slope, right? So that's what the MVT, the mean value theorem, says. So how do we prove this? In fact, the reason that we brought up Rolle's theorem first is that using Rolle's theorem we can actually prove this mean value theorem. So here's the proof of it. The mean value theorem. So we are going to define a function g of x Okay, it might be looking weird, but just bear with me. All right, I'm going to explain what this is. So g of x is defined to be f of x minus f of b minus f of a all over b minus a times x minus a plus f of a. Okay? Actually, this is not some sort of like a random function I'm talking about, all right? And, the inside the inside the brackets, right? This guy here. This is actually the line segment. The line segment joining to 2 points A, f of A, and B, f of B. So in other words, g of x is the difference between f of x and the line segment. So going back to my earlier picture here, right? So if we say, right, so say this is x, okay, that's x here, okay, x, then that's the line segment, Okay, so that equation inside the bracket is the equation of this line segment. So the difference, that's f of x minus that line segment. So this is going to be, let me use different color. So the difference here, that's going to be g of x. Okay, that's g of x. So that's what the function is about. Okay. Okay, so what do we do with this? First, notice that, so let, that's we define, that's what we define, okay? G of x. Then we see that g of a equals g of b equals 0, okay? And also, I mean, clearly you see that, the g of x is continuous. I'm not going to write that down, but g of x is continuous on the closed interval ab and also differentiable on the open interval ab. Furthermore, g satisfies this condition. So what does it tell us? G of x satisfies the conditions, okay, of Rolle's theorem, right? So by Rolle's theorem, what can you say? There exists a number c, right? There exists, yeah, let me remove this. There exists a number c in the open interval AB such that f prime of c. Okay, so here, what is f prime of c, by the way? F prime of c equals, oh, yeah, you know what? It's not f, it's g, right? G. Sorry about that. G prime of c, which is f of b minus f of a all over I forgot something here, right? Yeah. G prime of c, G prime of c equals, from this function here, f prime. Okay, so yeah, I forgot. F prime of c, F prime of c minus b minus f of b minus f of a all over b minus a, that's a linear function, so that's going to be 1. And f of a is also constant, so that's going to be 0, right? That's going to be 0. So minus here, okay? Right, so this whole thing has to be 0. This whole thing has to be 0. Meaning, right, so this implies that we have f prime of c equals f of b minus f of a all over b minus a. Done. So this completes the proof of mean value theorem. So we have this. Uh, there's a corollary of mean value theorem. If f prime of x equals 0 for all x in the open interval ab, then f has to be a constant function on the open interval ab. Okay, so here's the proof. So by the way, the idea is this. How do you show that actually f is constant? Well, the idea is, so you just pick two random numbers in the open interval AB. So let's call it x and y, and since these two are the different numbers, right? Two different numbers. So without loss of generality, we may assume that one is smaller than the other. So we might as well assume that x is less than y. Without loss of generality. Right. So in this case, f of x is continuous. F of x is continuous on the closed interval AB, AB, and also differentiable on the open interval xy. So by the mean value theorem in this case, right? By the mean value theorem, there exists a point z inside this open interval xy such that f prime of z equals f of y minus f of x all over y minus x. But by assumption, f prime of x equals 0 for all x in the open interval, so obviously f prime of z has to be equal to 0 as well. So this means since f prime of z equals 0, that implies that f of x equals f of y. So we randomly chose two arbitrary points, and f of x is always same as f of y. This means the function is continuous, right? In the in this open interval. So that completes the proof. Okay. All right. So let us take a look at a couple of examples, right, as applications of a mean value theorem. So first example, suppose there's typo. I gotta fix this. So suppose that f of 0 equals -3 and f prime of x is always less than or equal to 5 for all values of x. The question is how large can f of 2 possibly be, right? Okay. So I'm gonna get to my notepad to work on it. So here is the example, right? Example. So let us find that. Okay, so let me read this one. So f prime of x is always less than or equal to 5, right? Okay, less than or equal to 5. So we gotta remember that. So and also we know f of 0 equals -3. Now the question is how large can f of 2 possibly be? Okay, so by by mean value theorem, okay, so exists there exists C, okay, in the open interval 0 2 such that f prime of c equals f of 2 minus f of 0 all over 2 minus 0. Okay? And we don't know what f of 2 is, but we know f of 0, right? F of 0 equals negative 3, right? Negative 3. So that's going to be f of 2 plus 3 all over 2. But also, another condition says that, f prime of x is always less than or equal to 5. So, of course, this f prime of c is also less than or equal to 5. So, we just need to solve this inequality for f of 2, right? So, f of 2 plus 3 is going to be less than or equal to 10. Therefore, f of 2 is less than or equal to 7. So the largest possible value of this f of 2 is going to be 7. Okay, so that's easy, right? Now let's move to next example. A trucker handed in a ticket at a toll booth showing in 2 hours she had covered 159 miles on a toll road with a speed limit of 65 miles per hour. The trucker was cited for, there's another typo, okay. So the trucker was cited for speeding, and why is that? All right. Mean value theorem can answer that also. So for next example, the trucker drove 159 miles in 2 hours, right? So the average speed in this case, the average speed is 159 divided by 2. That's average speed, right? Which is 79.5 miles. Okay, 79.5 miles per hour. Okay, per hour. So actually, we have I can just write down mph, right? But then by the mean value theorem, okay, mean value theorem, this average speed is actually average rate, it's a mathematically like, the slope of the line segment, I was talking about, okay? So yeah, right, it's right here. So that's average speed, okay? So at some point, what the mean value theorem says, in terms of like, the physics involved here is that at some point in time, his, the truck's instantaneous velocity at some point in time is the same as this average speed, okay? So by mean value theorem, the trucker was driving at 79.5 miles per hour, okay? At some point in time. In other words, he was speeding, Okay, so yeah, he got a ticket. Okay, so that's the end of my lecture, and more details of my discussion here can be found in my lecture note at the following address. And as usual, this address is hyperlinked for your convenience. So just click on it, it'll take you to the lecture note page. And also, if you are interested in visiting my main blogger site, all you have to do is click on this word blogger, which is also hyperlinked. That's where you can find my other lecture notes. Okay, folks, thank you for watching and listening to my lecture. Bye bye.